Okay, since probably 1 p.m., we'll get started. And Professor Pierre has been traveling for Monday and Tuesday. So today I'll give a guest lecture. And today we'll talk about uncertain interest rate and the compounding. One thing before the lecture is that about the Excel sheet of yesterday's discussion will be emailed by the end of today. So today we will cover hopefully 3 topics. First is solving for unknown number of years. Second is solving for unknown interest rate. The third is compounding more than annually. So let's get started. First thing is solving for unknown number of years. I think many of you have faced this kind of question in your exercise or homework. So some problems require solving for a number of periods given the other parameters. I think most of you have be familiar with this kind of formula. Like we know the future value, and I want to future value. I don't want to know the present value, or I know the present value, and I want to know the annuity. Or I have the future value. I want to know the annuity. We can always solve for n in such kind of closed form. Let's have a look at this example. I want to ask how long will it take for $1,000 to be double in value at an interest rate of 5%. So we draw the cash flow diagram first. This is an infinite time, and in the year 0 at the beginning, we have a kind of investment, or we have kind of payment that is $1,000. And then in some future year end, we could have $2,000 payback. And now we want to solve this year end. So we know the present value, the future value, and the interest rate for every year, but n is unknown. So this kind of question is like, I know the future value and the present value, and I know P to NF and interest rate, but I don't know the n. So equation should be like this. The future value is $2,000, the present value is $1,000, and this formula is 1 plus the interest rate, which is 5% to the n, right? And we can solve this n in this closed form. So we use some algebra and move the 1,000 to the right. We could have 1.05 to the n equal to 2,000 divided by 1,000. So then we take logarithm of each side. That's correct. And then we'll have n multiple ln 1.05 equal to ln 2, right? If you have any question, feel free to raise your hand. And then we move the ln 1.05 to the left, and then n equal to ln 2 divided by ln 1.05. And the value of n will be 14.2067 years. But we know that we compound by year or by yearly, so it will take about 15 years to amass $2,000, right? Actually, it will be a little more than 2,000 because it only needs about 14.2 years to get this 2,000. So if you to see the values at the end of 15 years, it will be more than 2,000. That makes sense. And also, we can do this in Excel. Use the function of NPER, which is number of payment or number of period. So this function has, I think, has 3 necessary parameters. The first is interesting rate. The second is payment at the beginning. And this is future value. Sorry. will give the number of time period that requires for the $1,000 to be 2,000. I want to point that the present value is negative and the future value will be positive. Since at present I have an investment, for me it's kind of cash out. And in the future I have a cash income, which is $2,000. So for me it's a cash in. So one will be positive, one will be negative. So this is how we calculate this n in Excel. Use the function NPER. And then we move to the next topic, to solving for an unknown interest rate. So it may be of interest to determine the value of I that makes two streams of payments equivalent. And why? Because we could compare a series of payments to a fixed interest rate, and we could determine the attractiveness of the payments. Like we have two kinds of investment, which one is more attractive, which one is worth more money, and then it can provide a simple summary measure that if you want to measure two kinds of investment, there will be a lot of information, a lot of cash flow, but if you can compare these two investments by simply interest rate, you'll have a quick choice to choose which kind of investment. So we'll also take a look at this example. Assume you can invest $3,000 in a friend's business, and it will get payback of $5,000 in 5 years. And for what kind of interest rate of internal rate of return are those amounts equivalent? Here we have a definition of IRR, which stands for internal rate of return. So this is the interest rate that we want to get. We drew the cash flow diagram first. At the beginning, I invest a year 0. I invest $3,000 in my friend's business. So for me, this is cash out because I'll pay or invest this amount of money, right? And then, as is described in the question, we have we get a payback at year 5, which is $5,000. So this is a cash flow diagram for this question. And then it's become a question like, I know the future value, and I know the present value, I know the n, which is 5 years, right? So equation become like this. The future value will be $5,000, and the present value will be $3,000, and I don't know this I, so 3,000 multiple 1 plus I to the n, which is 5 years, right? To the 5 in this equation. And we use algebra, we do some movement, like we move this 3,000 to the left. We get 1 plus I to the 5 equal to 5,000 divided by 3,000, which is 1.667. So we open 5 times, we get 1 plus I equal to 1.1076, right? That's simple. And then we know I, it's about 0.1076, which is 10.76%. This is the interest rate that makes this, the interest rate of this project, which means this project is equivalent to earning 10.76% per year. So it's like, I think one of your homework questions asked about, I think it's question 2 asked about how much this company should earn, right? So this number tells me that if I have a choice of investing this kind of money in the bank, and the interest rate should be greater than 10.76%. Otherwise, I should choose to invest this kind of money to my friend's investment or business because it pays more, right? Also, we could use Excel function called IRR to calculate this value. This is much simpler than the former one. It's just a IRR, and then you include all the values. You'll get this 10.76%. So Anyway, it's just about how many numbers it shows. It's 10.76. So this is the function in the Excel that could tell you the internal rate of return. And also, this is one negative, one positive, because for you, one is cash in, one is cash out. But if there is an annuity involved in this kind of question, it becomes harder, because if there is an annual serial of the payment, this gets more complicated because there is one I, there's two I. If the I shows twice, one with an exponent and the other without. So it will become harder for you to solve this kind of problem. Sometimes this becomes impossible to get an exact value of I. And then we need to some other approaches. There are three approaches that could use. The first is, I want to show this first. This is IRR function in Excel. The other, you could try and error. You could guess which I this should be, and to plug in your guess in this formula, and to say, oh, if the left side and the right side are equal. But it usually take a lot of time because you can't guess exactly what I is at the first time, even at 10 times. So we need to know how to use interpolation, which is a second method to get this interest rate of return. And also, I have to mention that since you couldn't use Excel or laptop in your exam, interpolation is a method that's required for exam. And as explained in the former slides, since there's a two, one is to the exponent, and the other is not, but we have to use interpolation or trial and error to get this I. If every time there's an annual in this formula, we should use this method. Now, how to use that? As two options. One is trial and error, the other is using interpolation. The trial and error is just a guess. You should try different values of I until you have this equation valid or solid. And the other is interpolation. This trial and error are easy to understand because you make guess to say if whether the two sides of the equation become equivalent. So we will introduce interpolation. First, you need to know how to search for information at the back of your textbook. At the textbook, you'll have a lot of such kind of format of lookup table. Typically, it will be like this. Here, this table is for interest rate of 10%. Here is a 10%, and this is number of period or number of years. This 1, 2, 3, 4. This stands for F over P, P over F. How the value will be in this kind of situation or this kind of formula. Like I took this as an example. Since I know the present value, I want to calculate the future value. The formula will be 1 plus I to the n, right? If n equal to 1 and this I is 10%, it will be 1.1. And if 2 is 1.1 to the 2, which is 1.21. So this is a table you can look up to get the value of all this formula given this I and in this year. Is it clear? So it should be many tables for different I. This is a table for I equal to 10%. There should be a table for I equal to 7%, 6%, 8%, and 9%. This is the base. This is the basement that we could use. This is the foundation that we could use for interpolation. But as we know that in the formal example, the rate of the IRR is 10% and 10.76%, right? This is not an integer, which will not typically be included in the table, since the table will give you some integer interest rate. So we couldn't find directly from this table to say, oh, this kind of interest return should be what value. So we need to interpolate between two tabulated values to estimate. Since we know this is estimate, and the interpolation always gives an estimate. It won't give you the exactly value. The reason why is we use a linear model to do the interpolation. Actually, there are so many ways to do interpolation, like quadratic or other ways. But here we only use interpolation. But the exact conversion factors are non-linear. So this is the reason why there's an estimation, not exact value. So there's some errors in the interpolation. Typically, it's from 2 to 5%. You don't need to remember this number. Just tell you that they could cause some errors. But we could narrow this kind of error or make this kind of error smaller and smaller if we interpolate between the closer non-interest rate. Let's see how it works. In this situation, you are considering a project which costs $1,000 in year 0 and pays $144 annually for 10 years. You want to figure out the interest rate in such kind of investment or such a kind of cash flow. So the dividing tells us that A over P is 0.144. So the interest return should be something closer to this value, right? Let's look up the tables that we already know to find out if there are any interesting return that gives me the value near this 0.144. So we first check I equals to 7%.
You know that. Nice.
Sorry, maybe I'm too quick, too fast. If I'm too fast, you could ask me to go back at any time. Okay. And first, we look with the table that I equal to 7%, and we observe that when n is equal to 10, which is 10 years, we know that A over P here is about 0.14238, which is less than 0.144. And then we look, here's this value. Then we look at I equal to 8%. We observe that when n is 10 years or 10 time period, the A over P is 0.14903, which is this value. And this value is larger than 0.144. So we use these tables to find that there are two already known values. One makes the A over P less than the 1.144. The other makes the A over P greater than 0.144. So we know that the IRR, that's the interest rate we want to get, must be between 7% and 8%, right? And also, if you check the 5% table and the if you check the 5% table and the 10% table, you will also get one value is less than 0.144, and the other value is greater than 0.144. You can also use these two values to do the interpolation, but as we discussed in the former slides, the error will become bigger since you use some already known interest rates, which is far from each other. So we could say that if we use the 7% and 8%, it will give you more exactly value than 5% and 10%. So let's draw the map or plot here. This point here stands for 0.024 and 7. Which means the 7% at 7%, the A over P is this value, and this point stands for 0.025, I think it's 1409. It's 8%. So we use a linear interpolation. So we draw these 2 points and draw a line between these 2 points. This is assumed that the interest rate or IRR between these 2 points are linear. And then we could eyeball that the value that we want to calculate 0.144 is more closer to the 7%, right? So the IRR that we want to calculate should be something closer to 7%. And the plot also shows us as a factor over P increases, the interest rate I also increases. And then we will use the slope of this line to get the IRR. Since in this line, every 2 points in this line will have the same slope, right? It's a little algebra. And we will do like this. First, we could calculate this point and this point, this 9.2% minus 7%, and the x-axis value point. Right? We use these two already known points to calculate the slope of this line. And this value should be equal to any 2 points in this line that we use them to calculate the slope. So I appoint this point, and this point is what we want to know its value, right? It's something like I call it IRR star, and its x-axis value is 0.144, right? So you could use this point and this target point, or this point with the target point, whatever you use, they'll give you the same value to calculate the slope of this line. It should be, I use this target point and this 7% point. It should be IRR star minus 7% divided by 0.144 minus, which is 0.14238. Right. We use the IRR to minus this 7% and uses the interest rate of IRR to minus the interest rate of 7%. This is also the slope of this line, right? So since it's the same line, so this value should be equal to this value. And now we could to use some algebra to get the IRR here. The IRR should be I don't like this machine. Right? it's just simple algebra. I multiple this divider to this side and multiple it and plus 7%. And it will give me approximate value that I equal to 7.24, which is closer to 7%, right? As we told before, they say that this point is much closer than 7%, so it should be something bigger than 7. And this is just a calculation. And this 7.24% is a very close value or very close number. If you use tiny arrow, you could get a more exact value of IRR. But we will not ask this kind of question that we want to use to give some guess of more exactly IRR. This value will be enough. So let's see. Let's to check if this answer is correct using Excel function IRR. So this is the initial payment, $1,000, and this is 10 years with annually 144 income. It's 7.2459%, right? So this is how we interpolate, how we use interpolation to get this IRR. I just review this process. First, you want to know exactly what kind of situation you are in. And we use A over P to say approximately, to say the IRR we want to get. And then we go to the book, the tables, to look up, to find the nearest value for this target value, which is 0.144. And then when we find one ratio, it's lower than the target value, and one ratio is larger than the target value. And also, we want to find the closest percent to narrow the errors. And then we draw the map to get an intuition that how much the IRR should be. And then we use linear interpolation to get the value of IRR. And the function, the method here is to make sure this same line has the same slope. So interpolation is approximate, as I told you before. It's just give you an estimation, but it's close. It's exact enough for our calculation. And it requires one interest rate that gives a smaller ratio, one interest rate that gives a larger ratio. So the answer must be between these two. And the result will be more accurate when these two already known percent is close to each other. So that's interpolation. And I want everyone to understand this method and can apply this method by yourself, since you are using it in the exam. And then we'll move to the last topic about compounding over breaking the annual. I think all of us have faced this kind of question in discussion session or in some kind of exercise. So, for example, if we have an interest rate of 12%, it's an annual interest rate, and now we don't want to compound annually. We want to compound it to monthly. So the interest rate here for every month should be 12% divided by 12, which is 1%, right? But if we actually calculate this value, we can find that if we compound it yearly, the future value will be the present value, which is 1,000, multiple 1 plus the interest rate, this is in 1 year, so it's 1.12 multiple the present value, we'll get this value, right? 1,120. But if we compound monthly, we use this equation. to get the final future value, it should be 1 plus the monthly interest rate. Here is 1% to the 12, since there's 12 months in 1 year. And we will find the future value should be 1,126.8. It's interesting that this value is greater than the annual compounding, right? There's some intuitively understanding of this phenomenon. Since if I compounding by year, I could get only one interest at the end of the year. But if we compound monthly, we will have interest every month. And this month, the interest will be included into calculation in the next month. And this is intuitively the reason why this value is greater than this value, the yearly compound value. So the difference will be greater over a longer period. Since if you in longer period you have a more frequent compounding and you have more interest received before the end of the whole period. Like we have a look on this example. If we borrow our same $1,000 for 8 months at 12% yearly compound, if compounded yearly, we'll have $1,722.3. And if we compound monthly, which means we compounded over 60 months, the future value will be 1,816.7. So it's more than 3% greater. This is a phenomenon we call the nominal interest rate and effective interest rate. Oh, sorry, I'm too fast. And also, this is something that you face in the homework. And some people find that the first question that asked me to calculate the interest rate, I may have the different method with my friend, so you get different value. Actually, the one value you get is what we call nominal interest rate. The other is effective interest rate. So the nominal interest rate is frequently the value stated, especially for the bank for loans. Why? Like for example, if you want to borrow some money from the bank, the banker told you that I'll charge you an interest rate yearly. It's 10%, and I will compound every month. Why he said that? Have a guess.
What does M stand for?
This M.
Yeah.
M is if the M the times per year. Like this R is interest rate for every year. M is how many times I will compound if I don't use a yearly compound. Like in this formula, I will compound monthly, so divided by 12. The reason why is that the banker only told you a nominal interest rate, which is legal because he already told you how much it will charge and the interest rate for this year. But in reality, if he compounds every month, they will charge you more dollars than just the compound yearly, right? And we are more used to use a nominal rate to state the loan or states the interest rate. But some kind of investment or some kind of business, they calculate the interest by effective interest rate. So you should pay attention to some contract or agreement that you sign with bankers or any other industry. The term nominal means in name only. In other words, it's not the real interest rate. The real interest rate that take effective is the effective take effect. It's an effective interest rate. So let's take a look at another example. If we have an interest rate of 9% per year, but we compound it monthly, how the equation should be in the first year. At first, we need to know the effective monthly interest rate. Since the yearly interest rate is 9%, we need to divide it by 12. This is how many months in this year. And we get to know that the monthly interest rate is 0.75% per month. And then we calculate the effective annual interest rate. Suppose we have $1 at first. $1 multiple 1 this monthly effective rate to the 12. This is 12 months in this year, right? And minus 1, we will get the interest rate, which is effective interest rate, is 9.38%, which is greater than this one, right? It makes sense because as we stated before, the effective interest rate should be greater than the nominal interest rate because it compounds more. So let's see some pictures, say why this happened. Now, this is the time period of this year. And if we compound it yearly, we will have some money I'll use the red color to represent the yearly. If we compound the yearly, we have a cash out here, which is, for example, $1,000. Never mind, we won't use this number. And then we have a cash in at this point, right? This is the beginning of the year, and this is the end of this year. And I use green color to it should be green. Whatever. And we use this rectangle, triangle to means monthly compounding. If we this is a situation that we compound yearly. If we compound monthly, and at the first year, by the yearly interest rate of 0.75%, we'll have some kind of interest here, right?
Wait, on the previous slide, the equation. Wait, yeah, why is there a -1 effective annual rate?
This equation?
Yeah.
First, we want to know the rate every year because here, this value should be 1.0638, right? This is a factor that you multiply by your principal and you get the future value, right? I need to know the rate. I should -1 to see the rate, right? Does this make sense?
So if we're given a rate that's compounded monthly, is that also going to be the nominal rate?
You may just repeat your question, please.
If we're given like this, a rate 9% per year to compounded monthly, do we always consider 9% to be the nominal rate? Because the next slide it says the nominal rate.
Yeah, the 9% is a nominal rate, right? I mean, in this situation, In this situation, it states the 9% per year, right? This is a nominal rate that we compound every year. And this is an effective rate that's compounded every month, right? Right, clear? I think you don't need to struggle with this per year or per month. The compounding more than like the nominal rate is compounding like for n times. Like this is a time horizon, and in this time horizon, there is n times compounding, or even 1 times compounding. And the interest rate for this 1 time is called nominal. And the other way to compounding over the same time horizon is something greater than 1. And then this rate is, we calculate its effective. Does it make sense? So the difference is it's the times that's compounding between this in this time horizon. Usually we will choose this is per year because the every investment or the banker will say the interest rate of return is by year, right? So we back to this picture, and this is this one is a situation if we compound every year, and this rectangle one means the compound by month, and imagine that if we compound yearly, here we should have a value, right? It should be 1 plus 0.7% multiple your principal, right? And then next month, this will multiple the other factor, the other. So at the end, it will be principal multiple 1. To the tail, right? And this value only be principal multiple This is, as I told you before, intuitively how the effective rate is larger than the nominal rate, because every time in the smaller time period, the interest in the second month, the interest rate of first month will be compounded. That's a reason why it's greater than annual interest and annual compounding. Any question here? So we also have a quarterly interest or quarterly compounding that is compound every 3 months. Let's calculate. I hope everyone calculates by yourself now to say what is interest rate. I'll give you 3 minutes. Okay, let's say, does anyone have the answer? I don't have one.
9.3.
What?
9.3.
9.3? Anything else? Okay. I think that's the correct answer. First, we need to calculate the quarterly effective interest rate. And we calculate the effective annual rate, which is 9% divided by 4 and to the 4, because there's a 4 quarters per month, 4 quarters per month. And minus 1 will get you your answer by 9.3% per year. This is your effective annual rate. So, and also sometimes we may have weekly compounding. We assume completely 2 weeks per year, and also the 9% nominal rate, and the true effective rate, or true effective weekly rate should be this value, and the effective annual rate is the 9.4%. So this also is this bigger than quarterly compounding, right? Because if you compound every week, you are compounding more times than quarterly. And the rest of this lecture will be something that we just want you guys to know about that, but we don't need you to comment or do some calculation about continuous compounding. So before this part, we all calculate some discrete compounding, like every month, every week, every year. The time is cut by pieces. It's not continuous. It's called discrete. And now we may have some continuous time to compound, like the number of compounding periods is larger. You could say as a continuous time. And here is a nominal interest rate. And learn from the math, we know that the equation here should be equal to e to the r. Then the future value. If you want to know the improvement of this thing, I suggest you to read some books in the calculus or some math books. And the future rate will, for n years, compound continuously for n years with interest rate r, will be the principal or present value multiplied by e to the rn. And in continuous compounding situation, we want to get the effective annual interest rate. We should do the same thing. Just take the logarithm and try to find this r. That's just something that we take a look at. We don't need you to fully understand. So the first thing is this is the interesting rate, and we use this one to equal to 1 plus I to the n. This is discrete, and the takes open at times. E to the r should be equal to 1 plus I. The I should be e to the r minus 1. And to get the nominal interest rate from effective interest rate I, it should be, this one is the effective interest rate and equal to 1 plus nominal interest rate, and then take logarithm, we have r equal to ln 1 plus I. So why we use continuous compounding? Because some loans or investments are compounding that way. That's maybe not so Europe, but there's something in the finance or marketing area use this way to compound. And also it can be used to do module revenue that comes in continuously during a year. This is something usually be used in research or finance department paper because they need to calculate something in this way for some kind of use. And now we have a review or summary for this lecture. First, we need to know how to solve two things. First, it's an unknown number of years. It's used the closed form to get the value of n. And the other thing is This is analytical because we use a closed form to get the n equal to something that we could use this kind of formula to get the n. It's called analytical. And the other is to solve the unknown interest rate, which is numerical because we don't have exactly value. We just use interpolation. We use Excel function. If you are interested, you should look some information document of Excel function IRR to see how it calculates in the machine. And this is numerical because we only have the approximate number or approximate value of our interest rate. And also we learn something about compounding. And the important thing is discrete compounding. Discrete compounding, as I mentioned, the continuous is just something for you guys to know. We don't require some exams or some questions. And now we have two kinds of interest rate. One is nominal interest rate. The other is effective interest rate. You need to know how to calculate the effective interest rate, if you know the nominal interest rate, or vice versa. So I think that's all for today's lecture. If I'm too fast or if you have any question, I'm glad you could come to ask me. I will stay here for the rest of this class. Thank you. Make sure that if you come more times,
Yeah, that and I also have a question on the wording. So, this question, this is like the additional cost. So does that mean you can stick for a year or is it just saying that
you can do this in 2 ways. If you use this as an investment that can be paid back every year, you should say, just if I have a payback for 1 year, the payback maybe can be reinvestment in future life. In this situation, but if you use it as a full-time period, one-case time period, you may just find how much information in 5 years. Also, I think the other thing is also because the value of that you need to
this one is so I just didn't know because I didn't know I was supposed to catch up. I just didn't know.
Oh, yeah.
Okay.
I just want to ask you how you think so. Yeah, like why is this trusted? No, adding just to ask.
I'll see you later.
I did so much homework. Most people they just use the future present future formula to get how much it would be for the total of variance and just divide it by 5 to get the range. But I use the activity formula and give it is that wrong? Do you know what
This question.
by a certain
It's a second question, right? The
in the
investment.
other question, yeah.
This is just the word.
This question, right? This one?
Yeah. No, yeah. Yeah, we don't have this third question in our homework. This is this different.
Yes, it's different. Well, you please send an email about this thing and you
I have.
Did you solve that one?
Yeah. The teeny tiny division, the Dow. The new equipment costs 300,000 and is expected to last 5 years. How much additional profit would the company need to make each year as a result of the expected?
In real way, it's to me, it's an ability that if I want to make $2,000 in 5 years later, how much right? That's your fundamental presentation. So if I have $2,000, $20,000 right now, I want to make an investment or not. Because if I make this investment, the investment is 10% rate of return. If I calculate the calculation, I don't make this investment, I use this money to produce products. Only gives an interest rate of 9%. So obviously I should make the investment.
Also, so you use the F is equal to P times 1 plus I to the power of 5
Yeah.
to see that if you put, so your profit should be at least as much as it would be if you put the money in the bank.
Yeah.
Okay.
Actually, it should be more complex in this situation, but we don't need to use this version of our experiment here, because if you invest the money today, you have it's really compounding annually, right? So maybe you should have a do it every year instead of 5 years later. And that's fine. You do it 5 years later, it's fine.
Okay, and then just divide the final answer by 5, or would you need to do anything?
Yeah.
Okay. Thank you.
Yeah, no, I was just waiting.
Oh, sorry.
Question. For couples.
Oh, can I just ask one? Like, you know the discussion worksheet from yesterday that wasn't there? We will put
I think my discussion section, the news discussion, is basically the same material, and I post the material and the Excel sheet in the answer for all the students. I have not do it by the end of today.
On the third minute problem, we were using the future the F. So when you use this equation, you get that answer. But when you do the same thing, the Excel function, I was getting a different number. I didn't.
So it's your present value and future value. Does it say?
Oh, wait, what did you just change?
Because there's the parameter for this f3 function. So here, first is a rate, as you give us 15%, and then it's a time period, and then third is a payment, not the present value. Because you have this 10 million is a present value, and present value should be worse, and to put more common here.
Okay, that makes sense.
Every time you need to match the parameter with your
Yeah, perfect. Thank you so much.
I have questions about like the email case. So like so the PV is supposed to be like the amount of money that we have to pay, so that if we get money, so it should be a negative number. So that's what I get from you. Like that's what I get to understand from you.
Like this, in that, I still remember the question. It's like you have a cash out,
Yeah.
right? And
Yep.
cash in the 4 years,
Yep.
right? The Excel function, view that you use equal, I think it's a minus something like.
Yes.
And we try to try that for the present value.
Premium value.
Present value, right?
Yes.
And they have the 2%, the period, the number, right?
Yes.
Something, right? And the reason why it gives the wrong answer is they view this. You mean you put a negative number, negative here. It means a payment or cash out for you, right?
Yes.
And here Excel defaultly views this as a payment.
So if the positive number in a PV formula is for a payment.
Yeah.
So if we get the money, if we get it as a revenue or income, so it should be a negative number.
Yeah, because this is a payment for Excel. This is a payment or cash out for you. If I put a negative number here, it's a negative cash out, just a cash in. Negative cash out, it's cash in. So it doesn't. So it's not that the function is wrong or the formula is wrong. It's just you need to have a I think it's a constant standpoint. As standard U or standard bank, you need to be constant because here is a cash out, here should be a cash in.
All right. So is that all of the function in the Excel function is like this, or only like for present and future value?
I think most of them are because like the rate function, as I discussed yesterday, you need 1% or negative, but it depends. It also depends if you view this is the positive, this should be positive too. Right? It depends on your situation and your function. Does it make sense? Because if we stand at the point of the banker, right? Here it should be the cash flow will be different. The first year will be cash in, the other year will be cash out, right?
Yep.
And here will it's a cash in to you, so they'll be
Yeah.
positive.
All right.
This is also
Positive. All right. All right.
And I also recommend we use the because at the end of the discussion I couldn't think why immediately, and I use this evaluate function and to say,
Oh.
oh, this step should be positive, but it gives a negative.
Alright,
result. So
alright,
actually that one also, I strongly recommend you use this tool to figure out the wrong code.
Oh yeah, and I also have the question for the homework. So for the number one that we had, like the calculation part, do we have to use like nominal formula or effective formula that you explain to us? Like
It doesn't matter you use which one of them, but I suggest you use both to say that this is longer, this is effective, to show that you understand this concept, and also I think it's not too many words if you calculate both right.
yeah, it's not too many words. So like I get an email from like the other TA that said that it should be in the year percent. So like I know that 1 year, like the most of people think that 1 year is like 52. Do we use 52 like the legit 52 like round number or like 52 comma what?
Oh, you mean that the 1 year have 52 weeks?
Yeah,
normally, but it should be 52
Yeah.
point something, right?
Yeah.
It's fine because if you say I assume there's a 52 years or 52 weeks in a month. That's
All right. Yep. Thank you.
Hi, I have questions about the slide. So you're asking the questions that was asking about like why the bank use the nominal rate.
Sorry. Just say which side.
Maybe this one. What is the answer again?
Because actually it depends. It's a real life situation that if you go to the bank, you want to borrow some money, it should be like if I borrow for 1 year, there's an interest rate that the bank charges you, for example, 7%. Just an example. This is a normal interest rate, right? Because it's compounded every year.
That is nominal.
But this is nominal.
Okay.
But if, because there are some situations like that, but not every situation, if the bank actually compounds every month, so the effective interest rate should be greater than 7%, right? So this is the effective interest rate. So why the value state is nominal interest rate is because this will make you think that it's only charged 7%, but actually it's charged more than 7%.
Wait, so for the first year it will start with like the nominal interest rate,
First year,
right? Wait, sorry, what? So why the bank just tell the nominal interest rate when it actually compute the effective interest rate?
because for two reasons. The first reason is as usually the value we state for the bank or for any other finance department of financial industry is annual rate. It's just a tradition that we then state an yearly value, which is nominal interest rate. This is a tradition. The second thing is, as I told, if I just state the nominal interest rate, but in my contract with some detailed agreement, we actually compounded by week or by month. That is also needed because we may make your payment every month, your payment every week. So I do need to calculate by every month, by every week. So it may be doing this way in reality.
Oh, so then would that be like legal for them to
Sorry, come from China. This is some bank in China did do it this way, but I'm not sure it's legal or illegal.
Well, because they say something, but what they actually do is
Like I told you, it's a tradition that we all use a nominal interest rate, but it depends on how you pay back the money and how you. Because like, if you borrow money for 2 years, but you pay back for every month, you have 24 months, right?
Right.
After I pay the first month, after I pay some money in the first month, I